Hi, welcome to the Siemens Video Studio. I'm Berit Wessler, and I'm a Digital Business Manager for Siemens Smart Infrastructure in Switzerland.
I am Sandro Blatter. I'm a software engineer at Northern Engineering, but working closely in collaboration with Siemens Smart Infrastructure.
Today we are both happy to show you how digital twins can be utilized to make buildings smarter and to provide value to our customers. In particular, we would like to let you know how we brought together an iModel with IoT data of one of our customers' buildings. In addition, Sandro will show you the application that we developed by using the iModel.js SDK, and he will also show you how we managed to create a great visualization for showing the building information we retrieved. But before he starts with this, let me give you some background. So as some of you might know, Bentley and Siemens already have a long-term history. And this global alliance has been proven to be very successful in the process industry. For instance, I would like to mention the joint development of PlantSight, a plant operations software based on a digital twin solution. Or I could also mention Teamcenter Calm, software that manages capital asset data, which is also aiming to create a closed-loop digital twin. This win-win partnership is not only reflected by our joint innovation investment program, which was actually doubled in 2018, but also in the increased investment of Siemens into Bentley shares. Allow me to share one last example with you. Bentley and Siemens won a project to create a digital twin for one of the largest petrochemical complexes in Indonesia. By now, we mainly focus our joint development efforts on the process industry. But today, we would like to talk about digital twins for buildings and what business opportunities they can bring in the operation phase of a building. Let's clarify first. Our digital twin for buildings is called Building Twin from Siemens. And it combines structural data, so that means all the location information, with dynamic data that are gathered in the operation phase of a building. So the structural data comprise the building structure with the rooms and the floors and the spaces, the geometry, so the coordinates in 2D and 3D, and the equipment, also with its position. As said, the structural data are then combined with the time series data, and these can come from various kinds of equipments, such as sensors. Now, all these data are brought together in a common data model. The data model describes the relation between the assets, the floors, and the spaces, and we use a knowledge graph to model this relationship. The great thing about this is that all the data are machine readable and we can access them via our API. That means that we gain insights and knowledge on how the building is performing. And that actually brings me to the business part of it. For us, Building Twin is an enabler to serve our applications and services. So if you gain knowledge about the building and a deeper understanding at any time, of course, you get opportunities to also adjust the efficiency of the building and to optimize it. We can even imagine that we can improve the design of future buildings. Let me give you examples for more concrete use cases. The first one is space utilization. In that use case, location data are brought together with occupancy data coming from specific sensors. With an analysis of these data and a proper visualization, we can see immediately where the hotspots are. These are the areas which are too crowded with people. Now, the building owners and tenants can use these data to reconfigure their layouts. And that's actually a quite timely example now in COVID-19 times, because it enables the business owners to improve their layouts and ensure that people can actually keep their social distance. Another example is from a data center. Overheating of racks is a very critical issue in data centers. And the earlier this overheating is detected, the more damage can be prevented. If we provide real-time heat maps where the hotspots can immediately be detected, the people in charge are enabled to react immediately. And by this visualization in a heat map, they can not only see the hotspots immediately, but they can also see by this temperature gradient if the surrounding areas are affected too. Surely I can tell you many more use cases, but the point I would like to make here is that the visualization is a key element that also our customers are asking for. This is exactly what we did together with Bentley in a hackathon. We explored how we could bring an iModel together with IoT data and how we can provide an outstanding visualization. We took the iModel to deliver the structural data, and we brought it together with IoT data from various kinds of sensors. And as you can see on the images, it was quite an intense week and we had a lot of hard work. But we also had a lot of fun and great support from the Bentley team. But back to what we actually did. We started with BIM data of one of our customers' buildings that is actually located in Vienna in Austria. And he delivered 4 different Revit models to us. In the first step, we used the iTwin synchronizer, the so-called bridge, to populate an iModel with these data. In the second step, we used iModel.js to extract building structure data from the iModel into our knowledge graph database. On the other side, the connected devices in the building deliver data to the time series database. These time series data can also be accessed through our building twin API. As the Revit model has unique IDs, the mapping is possible with the time series data. In the hackathon, we then used different kinds of features from the iModel.js SDK and created a web application that can visualize the IoT data in the 3D model of that building. Let's now have a look how we realized it. Sandro, the stage is yours.
Awesome, thanks Berit for the great introduction and the overview. I have just one slide left before the presentation, so please bear with me. What I want to discuss in this slide is what feature was provided from where. So from Bentley we used the Synchronizer portal, the iModel hub, and also of course the iModel.js SDK to generate our hackathon application. From Siemens we provided the BIM data, the 4 different Revit models, also the building twin API and its data, and 2 components developed prior and after the hackathon: the multi-story navigation and also the graph visualization. What glues everything together is we have one unique ID in the physical programming of the building, and this same ID is at the same data point in our Revit models. With the stage now being set, let's move to our demonstration. So I want to first explain where this application is running. This application is running on my business laptop without any dedicated graphic card, just to bear in mind about the performance, what you will see. This hackathon application was born out of the 9-zone example. But we did change some things. So we added 2 stage panels. Stage panels are also a functionality from the iModel.js. Right-hand side is the building browser stage panel, and the lower stage panel is the sensor detail. I will first explain what the building browser is doing. It shows the different stories and rooms of a given building. So if I'm clicking on a story, you will see each level of this building. What is interesting is the item count here shows 8 stories, but the building has only 5. This is because iModels.js aggregates everything called a floor or a story into one, let's say data table, and this is the result of it. But if we click on a certain story, you will see that our viewer creates two clipping planes, slicing the model into different stories. Clipping planes are also functionality of iModels.js. And if we click on the different stories, not only the different stories are displayed, but also the list right here of all our data points, unique IDs, is filtered accordingly. What is also being filtered accordingly is this room list. So if we click on a certain room in here and zoom into it, you will see a slight blue highlighting of this room. But to enhance that and even more highlight this room, you can click on a certain sensor, which is now a multi-sensor, which reads the temperature and also the humidity. And if we select every sensor, only these will be shown. This functionality between these markers are called marker and is also provided from the iModels.js. And with that being explained, we now move to the different zones, to the two zones over here. I will first hit the loading button because it takes some time to load the last 24 hours of sensor data for this building. What this upper zone does is it generates a gradient which allows us to calculate the color for the different room sensor data. We set it now to dynamic to calculate the min and max value according to the min and max of the whole data from this given sensor type, which is now the room temperature. And now if we tilt this view a bit and move this into better view, you will have a better overview of this story. And if we hit on play, what now is being shown is an animation of this floor and also coloring changingly hourly to an hourly modus. And if we click now on a different sensor type, let's say concrete temperature, only this information will be shown in this map. What is also available is we can click on this sensor icon and only the CO2 will be shown for each room that has that information. What is also possible to read out the humidity of each room and color the rooms accordingly. But with humidity we have always one reading which is rather high. And to find that, we just delete the filtering to get a better overview of this whole building. And if we move that and rotate the building, we will see the exact room which is now reporting this high reading. And what I can do now is hit on this marker of this sensor which is sending this rather high humidity. These two applications in the sensor detail page come to life. So on the right hand side you will get an exact path visualization how to reach this sensor. It will take the stairs and the correct doors accordingly. On the left hand side you will see a graph visualization provided from D3 of the last 24 hours of data from this sensor. And that allows you to zoom in and look at a rather specific time when when the value is being received. How these three applications work is through a JavaScript interface. So the iModel.js application gives our unique ID, the BACnet ID, to each application. And these applications know what to do with the received BACnet ID, so either showing the data from the last 24 hours or show me the weight there. This allows for a borderless application that integrates three things into one, to have one easy to use application for all your needs. This concludes our demonstration, and now we'll head back to the slides. In the next slide, we have a summary of all our used iModel.js features. Now we arrive at our summary. We want to thank about this great support provided from Bentley during and after the hackathon. From my personal experience as a software developer, iModel.js was easy to learn, it had great possibilities, and especially for me, the open source aspect and the open development environment was just awesome. So you can reuse your application that you already programmed into these iModel applications, so you don't have to rewrite everything from scratch. But surely there are still some things to improve. So a better overview how to find features, because there are so many, more detailed documentation with implementations, and something more personally, better responsiveness and performance improvements on mid-tier devices like my laptop. Also, we have some set fighting artifacts in our application. These occur when two areas are flush to each other and the drawing program doesn't really know which plane is closer to the camera. It would be nice to have something like a developer guide how to mitigate those artifacts in iModel.js.
Good, thank you so much, Sandro, for these impressive results and also amazing visualization possibilities. So we both hope that you liked it as much as we did, and we are open now for your questions.